Hello, pre-algebra students. This lesson is all about using linear equations to solve problems. Specifically, our goal is to be able to use linear equations to represent, interpret, and solve real-world problems. None of the math we are doing in this lesson is really new. It's really just going to be more of us combining all of the different things we've learned in this unit on linear equations with a focus on real-world situations. So for this first question here, let me get my face out of the way a little bit. We've got Diamond's birthday is coming up and she is ready to celebrate. She plans on taking some friends to the movies. Each movie ticket costs $10 and she plans on spending a total of $25 on snacks. The directions tell us to create as many different mathematical representations as possible to show this information. In this unit, we have focused on being able to represent these stories in three different ways. Can you think of what those three different ways are? Well, one of them, I was trying to hide it a little bit with my face, but one of them is there's a clue right here. One way is with a graph. That's one way we can use math to represent the story. Can you think of another way? Another one is an equation. We've spent time in both Unit 2 and Unit 3 taking stories like this and writing equations to represent them. And then the final way is with a table. Tables are something you are going to see a ton in algebra. Almost every situation when it's something new we're introducing, we start with a table. And being able to create a table can really help you if you're having trouble with equations or graphs. So tables are always a good place to start. So in class, we do this as a warm-up. I would say take about maybe pause this video for 5 minutes, see how much of this you can do on your own, and then come back to see what the final answers for these might look like. Welcome back. In order to do these three things, the place we need to start, and I put it down here in the corner in purple, is with our variables. In order to create an equation, to make that table, to make that graph, this story has two variables, and we need to know what those two variables are. As you read through it, remember variables represent the things we do not know. One of the things we do not know is we don't know how many tickets she's buying. I know the cost of each ticket, but I don't know how many she has purchased. So one of our variables, maybe I'll call it X, could represent the number of tickets bought. I've had people describe it as like the number of people going to the movies. That would work too, because the number of people going is how many tickets she would need. But we need something like that, is how many tickets is Diamond buying. There's another variable in this situation. We can call it Y. I don't know how many tickets she's bought, and I also don't know the total money spent. Starting here by identifying those two variables is going to help us with the equation, because our equation is going to use X and Y. It's going to help me with my table, because those are going to be our two columns. And it's going to help me with my graph, because that's going to be my X and my Y axis. I had said with stories like these, if you're having a hard time figuring out the equation or graphs, tables are always a good way to start. When we go to create our table, one of the things we learned in the very first lesson is how I set up my table, and it had to do with independent and dependent variables. We said this first column is always your independent, the second column is your dependent. And so here, the total money she spends depends on the number of tickets she buys. So number of tickets would be my independent variable, and the total money spent would be my dependent variable. That would mean this first column in my table is going to be the number of tickets, and the second column is going to be the total money spent. So for example, I could start filling this in and say, well, if she buys one ticket, how much money is she spending? Well, we've got each ticket costs $10. So I know she's spending $10 on the ticket, but the total isn't going to be 10 because she also plans on spending $25 on snacks. So for one ticket, so if Diamond's just taken herself, that would be $10 for the ticket plus 25 for snacks. That would be a total of $35. What about if two people are going and she buys two tickets? How much would that cost? Well, we've got the $10 for each ticket from before. So for two people, that would be 10 plus 10 or 10 times 2, that's $20 there. The snacks, it says she's spending a total of $25 on snacks. So that's not $25 for each person. That's just a total of 25. So if I'm thinking through it, we've got the $10 for the two people, but then plus $25. That would be 20 plus 25. That's going to give me 45. Now you don't need that math right there if you just want to put 45 in your table, but I'm going to leave it just in case it helps some people. We can keep going down our table. So 3 people. Well, tickets are $10 each, so $10 for each of those 3 tickets plus my $25 for the snacks. So 10 times 3, that's $30 on tickets plus $25 on snacks. That is $55. I'm going to go 4, 5, and 6. If you were not able to make a table earlier, pause the video here and see if you can finish the table. If we keep going, the next 3 numbers, 35, 45, 55, this next one would be 65, then 75, then 85. And you might notice a pattern with these numbers. Every single time I add another ticket, the total money spent is going up by $10. That's because if I add another person, I'm just adding another $10 for the ticket. But that 25 on snacks isn't changing at all. It doesn't matter how many people are going, she is going to spend $25 on snacks. Now, sometimes you see our table start with 0 here. Based on the story, it seems really weird because you would think, right, if she's doing 0 tickets, she's spending $0. But it does say there's that $25 on snacks she's buying. So if we wanted to put 0 in our table kind of is starting at 0 tickets. She's still spending $25 on snacks. That seems silly, but I do have someone in my life who goes to the movie theater just to buy popcorn. They don't buy tickets. They don't see a movie. They just go because they really love that movie theater popcorn. So maybe they're this top person, this person buying 0 tickets, but spending a total of $25 on those snacks. Including that 0 is going to be helpful, especially when it comes to our graph. But this right here is our table. Now that we've thought through the math a little more, that can help us with our equation. Now, you were writing equations back in Unit 2 before we had even looked at tables, but seeing tables might help you understand it even better than you did before. When we go to write our equation, I'm going to describe the total money she has spent. So I'm going to say the total money she has spent equals what? Well, there's 2 places she's spending money. She's spending $10 on each ticket, and she's also spending $25 on snacks. When it comes to our equation, we're going to say $10 on each ticket. So that's 10 times the number of tickets, X. And then she is also spending $25 on snacks. That money she's spending starts with the $25 for the snacks, and then it's just going up $10 for each ticket. It's going up $10 every single time she adds another ticket. So now we've got our table and our equation. The final piece to this is the graph. And I mentioned it earlier, but I'll say again, if you did not get to the graph, now that you have a table and equation, this would be a great place to pause and see if you can come up with the graph yourself. Because remember, our end goal is, can you do all of this alone without in-person me or video me helping you? So if you haven't already tried to create a graph, go ahead, pause the video now and try. When it comes to making this graph, first I'm going to set it up with my x-axis and y-axis. So there's my y, and here's my x. Now when I'm setting this graph up, notice I'm not using one of these graphs where you have all 4 quadrants, because based on the story, my graph doesn't need to go into the negatives. I can't buy negative tickets, and my total money she's spending just keeps going up. It's not going to go into the negatives. When I go to set up my graph, my x-axis, it helps because I already used x and y. My x-axis is going to be the number of tickets. And I'm sorry about my voice. And then our y-axis is going to be the total money spent. Looking at the numbers in my table, I'm noticing I'm getting some big numbers. So on my x-axis, I would be okay counting by ones, but on my y-axis, I'm going to need to count by some larger numbers. So looking at this, I might make each of these darker lines 5, and I'm going to skip count. So I'm going to say every other line would be 10. So that's 10, 20, 30, 40. You get the idea of what I'm doing, like so. But then here across my x-axis, I think I'm good with each line just being 1. So I'm going to do the same thing, though. To save time, I'm going to mark every other number. And so those ones in between would be 1, 3, 5, like that. Okay. There's a couple ways you can create your graph. You can use this table we made, or you can use your equation. I'm going to use the equation since that's one of the skills we were learning in this unit, is can you take an equation and create a graph? When we are looking at this equation, each one of these numbers is important. When we go to graph, we always start with, do you remember? We start with this number here. What is this number going to represent on our graph? Well, that's our constant. That's the number without the x, and that always tells me my y-intercept. So it means my graph should start on my y-axis at the number 25. So 0 tickets, my first point goes right here at the number 25. Which, look, that's in my table, 0, 25. And then the other number we need, this number right here, what's that going to tell me? The number in front of x always, always, always tells you your slope. So if my slope is 10, and slope, I'm always thinking rise over run, that means my line should be going up 10 and over, to make it look like a fraction, over 1. My line should go up 10 over 1. That's coming from up $10 every 1 ticket. So starting at my 25, I want to go up $10. That would get me to 35 and over 1 ticket. Up $10, that gets me to 45 and over 1 more ticket. And notice all of these points I'm marking, like the next one would be at $55 for 3 tickets. All of those numbers are in our table. $55 for 3 tickets. You can keep doing this again and again. Up 10 over 1, up 10 over 1, up 10 over 1. But once you've done it enough times, you start to see your line. This right here would be the graph of our line. One of the things we have not talked about as much in this lesson, but I want to talk about now, is why it's helpful to have all 3 of these. Let's start with the one we just did, the graph. We love graphs because graphs are pictures, and pictures can give you a lot of information really quickly. For example, when I look at this graph, I can see the total money spent is going up. That immediately tells me something about the situation. And that makes sense with the story, right? The more tickets she buys, the more money she spends. Graphs are great to give you an idea of how it's changing, right? Is the line going up or down, or is it not changing at all and you've got a horizontal line? And graphs can also be helpful for the same reason tables are helpful, as it gives me a bunch of different examples with those points. A table does the same thing, where, for example, I can look at my table and see 4 tickets cost $65, or I could look at my graph and say 4 tickets, takes a little more work, but 4 tickets cost $65 and get that save information. Tables, though, do it a lot quicker. So we love tables because it gives you a lot of different examples. For example, if Diamond decides she's going to have 6 people going, she can immediately see from this table it costs $85. One of the downsides, though, to tables and to graphs is it doesn't give you all of the possible information. For example, maybe Diamond has a ton of friends and she needs 20 tickets. If I look at my graph, the number of tickets doesn't go to 20, so I can't look at my graph and get the answer. And my table also doesn't go to 20, and so I can't look at my table and get the answer. That's where equations can be super, super helpful. Equations describe what math is happening in the story and kind of give you like a recipe to finding that answer. When our equation says y equals 10x plus 25, it's telling me to figure out the total money spent. You're going to take 10 and multiply it by how many tickets, like 20, and then add in the 25 there. So my equation tells me if your graph in your table can't show you how much 20 tickets cost, to get the answer, this is what you've got to do. 10 times the 20 tickets, and then add in the $25 for snacks to get your answer. Equations are super helpful because they tell you how to find the answer for any number you want to choose. 1 ticket, 5 tickets, 20 tickets, 100 tickets. So it tells you, like I said, the recipe for getting the answer. The downside is just it doesn't give you any answers like the table and the graph do, right? I don't have the answers right in front of me. I do have to do some calculations. In math, there is value to having all 3 of these. So we started looking at equations, tables, and graphs in pre-algebra, but you are going to continue to see them in algebra for linear equations like this, in addition to other relationships you are going to see. This first question here was all about giving you an opportunity to practice using what you know about equations, tables, and graphs to go with the story, with the focus on can you create these 3 things. One of the goals in this unit is by the end of the unit, which is today, we want to make sure you're able to create an equation, a table, and a graph. The second part of this lesson is really going to focus on up here the interpreting and solving part. So if I give you an equation, a table, or a graph, can you interpret, can you understand what those are saying, and then use them to solve different problems? So for our part 2 here, this is the story we are given. I'm going to encourage you, go ahead, pause this video, read through the information, and start seeing what do you notice from the graph that is given and the table that is given. It is always helpful when you get new things like tables or graphs before jumping right into all of the math questions. Study them first and see if you notice anything. It'll help you with the math questions coming up, I promise. Go ahead, pause the video now, read through the stories, and see what you notice about the graph and table. When I go through these, one of the things I notice is we're talking about 2 different cities here. This first graph represents the snow in Indianapolis, and then the table here represents the snow in Chicago. So unlike our graph and table above, these are representing 2 different things. Looking at this graph about Indianapolis, some of the questions I might ask myself is, what is happening in this graph? It's showing snowfall. What's happening to the amount of snowfall? Usually in class, one of the first things people tell me is the line's going up. And absolutely, it means the amount of snow on the ground is going up with time. So going up over as hours go by. One of the things I could push you to do is, could you tell me how much snowfall it's going up by every hour? Thinking through questions like that might be helpful. But right away, people usually notice it's going up. Looking at the table in Chicago, same question. And I often also get, it's also going up, right? If you look at the numbers in these tables, as the hours go by, the amount of snowfall in inches, these numbers are also getting bigger because after time goes by, there's more and more snow on the ground. But again, see if you could push yourself to figure out how much it's going up by. being able to attach a number there is also going to be helpful. Maybe you also paid attention to where we are starting at, because that's been one of the themes as we look at these graphs and tables, is noticing where we are beginning. So looking at this graph of Indianapolis, you might make a mental note and say, I notice it's starting before the storm comes. The very beginning, it's starting with this much snow. Or the same thing at our table, noticing before any hours have gone by, do you see how much snow it's starting from here? These are questions that we sometimes talk through in class, especially if students notice some of these things. But again, these are all good questions to ask yourself before you jump into the questions, because you're going to see a trend that some of those things you might have already thought through are going to be questions that come up in a moment. So using this information, the first question for you is, comparing Indianapolis and Chicago, which city got more snow per hour? And like all of our questions, be prepared to explain your reasoning. If you did not already think through this question, pause the video here and see if you can calculate how much snow per hour each city is getting. We're going to need to be able to know both to help us compare them. Go ahead, pause this video now, and then come back to see how you did. If we're being asked about how many inches of snow per hour each city is getting, that is connected to one of these mathematical things you have learned in this unit. That is asking us about slope. Slope, remember, is telling you the rate of change, so how much these lines or situations are changing over time. And so snow per hour gives me a sign that I want to find slope. When we talk about slope of graphs, that's where that formula rise over run comes in. If I wanted to know how much snow per hour Indianapolis is getting, I need to choose any 2 points on our graph and calculate rise over run. When you go to calculate your slope, remember you can use any 2 points you want. A lot of people like to use this first point. I'm going to be different, and I'm going to choose this point here and this point here, just to show you it does not matter which 2 points you pick, we all should be getting the same answer. When you calculate your slope, rise and run are just telling you how much you have to go up and over to get from one point to the next point. So for example, starting on the left here, I'm starting at this point. My rise would be how much I have to go up, and my run would be how much I have to go over to get from one point on my line to the next point on my line. And drawing that triangle helps so much because it's showing me exactly what I would need to count. I'm going from, this would be 4 inches up to 8 inches. So that's 4, 5, 6, 7, 8. That's me going up 4 inches and over 2 hours. My rise over run would be 4 over 2, which is 2. I have just figured out that in Indianapolis, it is getting 2 inches per hour. And I could double check that just by looking at some other points on this line. I see hour 1, it's got 2 inches. Hour 2, 4 inches. Hour 3, 6 inches. Hour 4, 8 inches. Then 10 inches. Yep, it matches with it's going up 2 inches every hour. For Chicago, this one's a little different because we've got a table. But to find the inches or the snow per hour, it's that same idea. I need to figure out how much it's going up after each hour. And so looking at our table here, I might see to go from 2.5 to 4. Do you know how many inches we went up? Some people can look at this and just see what the number is. If you are not one of those people, you can always use the related math, subtraction, to help you figure out it is going up 1.5 inches. So from hour 0 to hour 1, it went up 1.5 inches in that 1 hour. And notice it's a pattern. It's going to keep happening. Another hour goes by and it went up from 4 to 5.5. That's another 1.5 inches. And then from hour 2 to hour 3, that's another hour. And it went up another 1.5 inches. So we're saying here for Chicago, Chicago is going up 1.5 inches per hour. Even though it didn't use the word slope, we are looking at slope here. So once you figure out that our graph of Indianapolis is going up 2 inches per hour and our table of Chicago is going up 1.5 inches per hour, which city gets more snow per hour? We can say, well, 2 is more. So Indianapolis gets more snow per hour. For the explain, there's lots of different ways you could do this. You could say, you could include Indianapolis gets 2 inches per hour and Chicago gets 1.5 inches per hour. We love when you actually tell us the numbers you calculated to help you decide. Or you could use some vocabulary like slope. So we could say, explain your reasoning. We could say, I compared the slopes. And 2 is more than 1.5. I'm trying to get like all the math points here. I'm using the word slope, and I'm also using an inequality to compare them. This first question was all about slope. Going down to our second question, the second question asks, which city has more snow on the ground before the storm arrived, and what part of the graph tells you this information? Again, pause the video here and see if you can figure out which of these cities has more snow on the ground before the storm arrived. I cleaned away all of our notes about slope so that we have space to talk about the second question. If I'm asking about before the storm arrived, that means we're talking about hour 0. Hour 0 means 0 hours have gone by, which is before the storm arrived. And that is all about, do you know where we're going to look on our graph? That is all about our y-intercept. That's going to be the answer to the second question, which part of the graph tells you this information. I'm looking at my y-intercept. So for Indianapolis, I see our y-intercept, our graph starts right here, and that is the point 0, 0. That means at hour 0, there was 0 inches of snow. In our table, it's already written as a point. We've got right here, this is our starting point. At hour 0, there is 2.5 inches of snow. So which city had more snow on the ground before the storm arrived? That is going to be Chicago. And what part of the graph tells you this information? We've already said the second part of that question is going to be the y-intercept. Question number 3, 4 hours into the storm, which city has more inches of snow on the ground, and how did you arrive at that conclusion? At this point, we said Indianapolis is getting more snow, but Chicago started with more snow. At hour 4, which city has more snow on the ground? You've got a graph and a table to look at. See if you can figure out which one it's going to be. For this question here, we're focused in on hour 4. So when I look at my graph here, hour 4 would be right here. I'm just going up to my line to see where it is. It's right here. And so at hour 4, I can see there is 8 inches of snow in Indianapolis. And I can even label it as a point. Hour 4, there is 8 inches. When it comes to my table, though, I'm in trouble because I don't see hour 4. But we can use everything we have said before to help us out. Hour 4 would just be the next row in my table. And we already figured out the pattern is every single time it's going up by 1.5 inches. So to find my missing number, I would just want to do 7 plus 1.5 because Chicago is getting 1.5 inches every hour. And I can see hour 4 is going to have 8.5 inches in Chicago. So based on this information, which city has more snow hour 4? It's going to be Chicago. How did you arrive at this conclusion? We did 7 plus 1.5. Chicago, it has 8.5 inches. And Indianapolis, only has 8 inches. One final question for the final lesson of our final unit of pre-algebra. This is the final question separating you from the end. It says, write an equation to represent the total inches of snow in Chicago after X hours. Coming up here, can you write an equation to go with Chicago? Pause the video, try this, and then come back to see how you did. So write our equation. We said writing equations are all about this formula, y equals mx plus b. And the nice thing about this question is you've already done all the hard work. We already found earlier our slope is 1.5. And we already found earlier our y-intercept is 2.5. My equation, therefore, would be y equals 1.5x plus 2.5. That means that Chicago is starting with 2.5 inches of snow, and we're adding 1.5 inches every single hour. So our final equation, y equals 1.5x plus 2.5. And remember, you can always have those terms in a different order. So you could write something like 2.5 plus 1.5x. That would also be okay. But y equals 1.5 plus 2.5x, that's not okay. You can't move where the x is. If you wanted, just as a bonus, you could also do that for Indianapolis. Indianapolis's would be y equals 2x. And since my y-intercept's at 0, that means there isn't like a plus or minus a number there. It would just be y equals 2x for Indianapolis gets 2 inches each hour. I love this lesson because you get to practice a ton of things that we have learned in this unit. Hopefully you are feeling more confident and comfortable with linear equations after watching this video. Thanks so much for watching. Have a great day.